An active filter is a circuit designed to manipulate signals. They are created with the intent to pass, reject, amplify, or dampen these waves based on their frequencies. Some examples of these signals include sound and light, which allow the filter to have many applications in transmission and communication fields. Active filters differ from other filters and are often more useful in many ways. A distinguishing attribute is that they are comprised of active components, such as op-amps, which give it the unique ability to amplify or dampen. They are also often the cheapest and easiest to create and use. An active filter is still very similar to the basic filter you are familiar with. Just like a filter for, say, a fish tank, an active filter in circuits cuts out unwanted gunk. In order for a fish tank's water to stay fresh and clear, the water must be run through a filter that catches all the debris produced by the fish and its system. An active filter works in a very similar way. Say a specific boosted frequency range of sound is desired from a broad signal containing lots of noise. A specially designed active filter will isolate the desired frequency range, eliminate all of the noise and unwanted frequencies, and amplify the output signal, all in one pass. An aquarium filter produces a clean fish tank, just like an active filter produces a desired signal. The active filter was created based on the inferiorly designed passive filter. As said before, one of the main differences between them is the fact that the active filter utilizes active components, like op-amps and transistors, to increase functionality. Another difference between the two is seen in their passive component makeup. A passive filter uses resistors, capacitors, and inductors, whereas the active filter only uses resistors and capacitors. Inductors tend to be quite costly and large, which is why they aren't often integrated into smaller circuits. Though passive filters do have restricted applications in electronics, active filters have basically dominated the filter game. A good example of electronics that use an active filter is an equalizer. An equalizer is a well-known component of stereo systems. Within these systems lie complex networks of active filters, some of which make up this component. Thanks to the active filters within it, the equalizer determines which audio frequencies must be amplified or suppressed to produce the best sound quality and power efficiency. Most equalizers are variations of a bandpass filter. The bandpass is made up of three special active filters: low pass, high pass, and inverting. All these active filters work together to manipulate a noisy input into a desired output. This is only one example of active filter use. Believe it or not, most of the electronics we use today contain hundreds of these little devices.